Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
This one question lost more marks than any other on last year's AQA paper, and it's actually easy if you know the trick. Students wrote down wrong signs, forgot to divide by the leading coefficient, or simply didn't show the rearrangement that wins method marks. Sound familiar?
Stay with me for the next 12 minutes and you'll be able to turn any quadratic into vertex form, solve it, and pick up the marks examiners hand out for method. We'll work one clean example. I'll explain exactly why halving the linear number works, and I'll give you a 10-second check to catch silly mistakes.
Right, the worked example. Take x squared plus 6x plus 5 equals 0. That's x squared plus 6x plus 5 equals 0. No fancy steps, just a simple quadratic where the x squared coefficient is 1. We'll complete the square and solve it. First step, group the x terms together and move the constant to the other side.
Write x squared plus 6x equals minus 5. Now the key idea, we want to make the left-hand side into a perfect square, something like x plus a all squared. When you expand x plus a all squared, you get x squared plus 2ax plus a squared. Compare x squared plus 6x with x squared plus 2ax. So 2a must equal 6, which means a is 3. That's why we halve the linear coefficient. It's solving 2a equals b. Let that sink in.
So halving 6 gives 3, and then we square 3 to get 9. Is that the a squared we add?
Exactly. We add a square, which is 9, to make the perfect square. But because we can't change the equation, we must add the same thing to both sides. So x squared plus 6x plus 9 equals minus 5 plus 9. That leaves us with x plus 3 squared equals 4. Now take square roots. X plus 3 equals plus or minus 2. Solve. X equals minus 3 plus or minus 2, giving x equals minus 1 or x equals minus 5.
Right, so the roots are minus 1 and minus 5, and the vertex form is x plus 3 squared minus 4, because x plus 3 squared equals 4, so moving 4 over gives y equals x plus 3 squared minus 4. That tells us the vertex is minus 3 minus 4. Spot on. Now, a short note on preserving equality. When we add 9 to the left-hand side, we also add 9 to the right. That's basic algebra. Whatever you do to one side, do to the other. That step is what wins you a method mark if you show it clearly. A quick mention for non-mnemonic quadratics, where the x squared coefficient isn't 1. Example, 2x squared plus 8x plus 3. Factor the leading coefficient from the x terms. 2 into x squared plus 4x plus 3. Inside the bracket, halve 4 to get 2, or x plus 4, plus 3 minus 2 times 4. That gives 2 into x plus 2 squared minus 5. Vertex at minus 2 minus 5. Let's move to the examiner's view. This type of question is typically worth 3 marks on a GCSE paper. Mark breakdown example. M1 for setting up the equation correctly and grouping terms. M1 for the correct completing the square step, showing the half and square, and A1 for the correct final answer. So if I don't finish the arithmetic, but I show the correct completing the square step, I can still get method marks.
Exactly. Write down x squared plus 6x plus 9 equals minus 5 plus 9, or show you halved 6 to get 3 and squared to get 9. That's the M1. If you then show x plus 3 squared equals 4, that's the second M1. Even if you don't continue to square root correctly, you'll usually keep both M marks. Always write the rearrangement. The examiner wants to see your method, even when the arithmetic slips up. That's marks are there for the taking.
Top 3 examiner pitfalls. 1. Not factoring the leading coefficient in non-mnemonic cases and then adding the wrong amount. 2. Sign errors, adding where you should subtract or vice versa. 3. Not showing the intermediate step
add same to both sides, so you lose the method mark. Write it down, don't just think it. Any tips for avoiding the sign mistakes? I always mix up plus and minus when moving terms around. 2 simple habits. 1. When you move a constant across the equal sign, say out loud, move to the other side, change sign. It slows you down just enough. 2. After completing the square, tidy the equation on a new line so you can see both sides clearly. Read the question twice, solve it once.
Now, your quick win, something you can use immediately in the next practice paper. First, the 10-second check. After you find your roots, substitute one root back into the original equation to check it satisfies the equation. That single check catches about 90% of silly arithmetic errors.
Second quick trick. Use the mnemonic half, square, shift. Half the linear coefficient, square it, and shift it to make the perfect square. Say the phrase before you start completing the square, and you'll remember the sequence every time. This is a grade 9 move when you use it consistently under exam pressure.
And the vertex form helps with maxima and minima too, right? Yes. Once you've got y equals x plus 3 squared minus 4, you read the vertex straight away, minus 3 minus 4. If the coefficient of the squared term is positive, the parabola opens upwards, and the vertex is a minimum. If it's negative, it opens downwards, and that's a maximum. So you can answer optimization questions in one line. Minimum value is minus 4 at x equals minus 3. Don't skip the check.
Quick extension. Sketching the graph from vertex form. Plot the vertex, then use symmetry. The roots we found, x equals minus 1 and x equals minus 5, lie the same distance either side of the vertex, at x equals minus 3. That gives you a neat quick sketch labelled vertex and intercepts, which examiners love.
A short exam-style prompt for you to try after listening. Complete the square for 3x squared minus 18x plus 11 and state the vertex. Pause the episode and try it. Factor the 3, use half, square, shift, and watch your method marks add up. If you want the worked solution, it's on the site. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.